Welcome to The Explainer. So today we're diving into this, well, it's like a huge philosophical crack in the very foundation of artificial intelligence. It's a problem that gets at why a machine can absolutely dominate a chess, but you wouldn't trust it to make a simple cup of tea. It really shows you just how wide the gap is between a computer's logic and, our own basic common sense.
So here's a real head-scratcher for you. How is it that an AI can beat a chess grandmaster, a genius at the top of their game, but then completely fall apart trying to do something as simple as making tea? And no, this isn't some hardware bug. It's a really deep paradox that has been tripping up the smartest people in AI for, like, half a century.
Okay, to really get this, picture this scenario. You ask a super logical robot to just grab a book from a shelf. Simple, right? Well, it might get stuck for hours trying to calculate if the moon's gravity has moved the book by a single nanometer. Seriously. See, the problem is, it doesn't automatically know what to ignore. It's forced to think about every single ridiculous possibility. And that brings us to the very heart of a central problem in AI. And it's got a pretty strange name.
So that leads us right here, to the infamous frame problem. And yeah, the name is actually a perfect clue. It's all about how an AI frames a situation, figuring out what's inside the frame of what matters and what's just noise outside of it. Okay, so what is it really? Simply put, it's this. An AI just struggles to figure out what's relevant and what's not when something happens. Think about it. When you do anything, your brain just instantly throws out all the stuff that doesn't matter. An AI doesn't have that gut feeling. It has to be explicitly told every single thing.
All right, let's try a simple experiment. Just imagine clapping your hands, right? Your brain immediately knows this only affects, the air right around you and maybe makes a sound. A purely logical AI, it has no idea. It doesn't have that intuition. You literally have to tell it everything in the universe that didn't change because you clapped.
And this is what researchers call a combinatorial explosion, which is a fancy way of saying the possibilities just spiral out of control. The poor AI has to go down a checklist of basically everything in the universe. Did the color of the sky change? Wait, has the Eiffel Tower moved? It's completely paralyzed. And this whole mess really comes from these early AI systems that were built on something called situation calculus. It was this formal logic for mapping out a changing world. A brilliant idea, really, but it accidentally created a robot that overthinks absolutely everything.
So, you have to wonder, how did the first AI researchers even try to tackle this? Well, they went with a really direct approach. Let's call them team logic.
Their whole philosophy was pretty straightforward. Intelligence, they thought, is just about manipulating symbols. So the plan was to build this enormous database of facts about the world. These are called axioms. And then create a super powerful logic engine to think about all those facts. The ultimate goal? Basically to build a brain in a jar.
But not so fast. Philosophers, especially this one guy, Hubert Dreyfus, they pushed back on this idea hard. They basically said this whole brain in a jar thing is totally, fundamentally flawed. And as this quote gets at, our human common sense isn't just some neat list of rules we follow. It's this rich, intuitive, and this is the key word, deeply embodied sense of how to be in the world.
And you know what? That really powerful critique, it opened the door for a completely radical new idea about what intelligence even is and how you might go about building it. So let's meet the other side, team body.
Now, this is a totally different way of looking at intelligence. Team body's main argument is that you just can't have a mind without a body. Period. For them, intelligence isn't something you calculate in a vacuum like that brain in a jar idea. No, they believe it emerges from actually physically interacting with the world around you.
And their solution? It's this really game-changing idea called relevance realization. So instead of trying to calculate what's irrelevant, an AI with a body just realizes it. It learns that the color of the sky has nothing to do with picking up a book because it's physically tried to pick up a book thousands of times. Relevance isn't calculated, it's discovered through trial and error, using its sensors and motors, not by crunching logic.
And you can really see these two philosophies in action today. On one side, you've got this top-down approach, where we're basically just trying to pour a bunch of facts into an empty digital head. And on the other side, you've got bottom-up learning. You see, robots like the iCub, they aren't programmed with facts. They learn by playing, by exploring, pretty much exactly like a toddler does. One side is trying to code common sense, and the other is hoping it will grow.
Okay, so where does this huge debate leave us then? I mean, it really boils down to this fundamental question. Is true intelligence something we can write, like a piece of software, or is it something we have to grow, like a living creature?
So here it is, the fundamental choice in front of us. You've got Team Logic, who believe intelligence is basically a coding problem. We just need to write a big enough rulebook, right? Then you've got Team Body, who say no, intelligence is more like a biological problem. We need to throw out the rulebook entirely and let an AI with a body learn its own rules through actual lived experience.
And this is the really crucial point, the big takeaway. If Team Body is right, if the frame problem really is impossible to solve with pure logic, then our whole sci-fi idea of a disembodied superintelligence, just living in the cloud, that might be a complete fantasy. It means that to build a truly smart machine, we might have to build it a body first.
Which really leaves us with this one, final, provocative question. What if the real path to true AI isn't through faster code and bigger computers, but through giving it a physical life? I mean, that just shifts your entire perspective, doesn't it? It moves us away from thinking of AI as just a program that we write, and towards seeing it as a kind of creature that might actually need to live a life just to be able to understand one.